Hi, this is Mark, G0MGX. I've got hold of one of these QRP Labs QCX CW transceiver kits. They were as rare as rocking horse manure, I think, and certainly the number of orders well outweighs the number of kits that have been shipped so far. I think there's a bit of a wait for shipping. This was originally developed for the IOTA meetings that were held in the UK in 2017. And QRP Labs is run by Hans Summers, which is G0UPL. Very popular, very good sets of kits. They do some other bits and pieces as well. I've got one of their Ultimate 3 transmitters here, which does some whisper and some QRSS beaconing from the house. But this is the CW transceiver, the QCX kit. I thought I'd do a quick video of the construction of this, so take you from the packet of bits that arrived today to hopefully a fully working transceiver. So let's have a quick look at what we've got. So we've got a 18 mega processor of some sort, in line with all of the QRP Labs kits. They all use the same technology. We've got a LCD display wrapped in bubble wrap. This is the low pass filter. My kit is for 30 meters. I made the mistake of thinking that this should have a circuit board with it, but it doesn't. This fits on the main board, I understand. So this is just the parts for the low pass filter. But if you buy the low pass filter separately, it does come with its own circuit board. And then we've got the main PCB here, which is a very nice through-hole plated complex circuit board. And there's two surface mount components already mounted on the board here. So there's no SMD components involved in this kit. It's purely through-hole technology. So the surface mount soldering has already been done, and it actually looks like, from the quick look I've had at the instructions, it looks like the most tricky bit is going to be this transformer here, but we can talk about that more when we get there. We've got some resistors, and then we've got all sorts of bits and bobs in this bag. So there's 1, 2, 3, 4 different bags of components. We've got a set of dual inline chips plus a socket for the 80 mega processor. And here we've got some knobs, some resistors, some presets, some jack sockets. Here we've got a toroid, some preset capacitor, crystals, a couple of transistors. Here we've got a BNC socket. There's a rotary encoder, potentiometer, some circuit board connectors, capacitors again, and here transistors. They look like small value ceramic capacitors and some fairly small electrolytic capacitors. So quite a lot of bits. 3 values of resistor by the looks of things. The circuit board with the surface mount pieces on it. If you go onto the website for QRP Labs, you can download the build instructions for the kit, which stems to some 135 pages, I think. So I'm going to start this project now. I'll duck in and out with a bit of video as I go, and we'll just see how we get on. So the first thing I've done actually is to print out this this sheet of paper. It's one of the pages from the instruction manual. This gives me a really good detailed clue as to the location of every one of the components on the board, so that I can make sure I'm putting things in the right place. The first piece of instruction is to install the socket for IC2. So I've got hold of that. I've bunged it in the holes just to make sure that the dimple is aligned. Turn it over, and I'll have a go at soldering this now in front of the camera, just to see how well or otherwise this works. I'm using an Antec soldering iron. It's got a fairly fine tip on it, but certainly not tiny by any means. I wouldn't use this for surface mount soldering probably, but it seems reasonably good. And a fairly thin solder. It's from Rapid. It's 22 SWG and it is leaded. I try and avoid the lead-free solder. The soldering iron is at 370 degrees from a rework station. So this isn't just a plug-in soldering iron. This is actually one that's temperature controlled. Just need to give the tip a bit of a clean. There we go. So let's solder this in and let's just see how we get on with this. What I tend to do with these is to do one of the corners, get the joint good, and then make sure that the socket is actually tight to the board, pushing it from the other side, and then do one of the other far corners. And again, I'm going to just heat that up again and push hard from the other side of the board. So that's on fairly neat, square and tidy. So I'm just going to run down the other pins of this IC socket until it's secure in the board. You don't need a lot of solder or a lot of heat. A lot of soldering really is about patience, I suppose, because if you rush it, things can go wrong. So this is the IC socket for the main processor on the transceiver. I think it's 24 pins, 12 each side. So there's one half of that done. I don't know how well that's going to come out on camera. Just make sure the focus is where it needs to be. Hopefully you can see that. I'll run down the other side now. So hopefully this might be a slightly better angle for you to see close-up of the soldering iron and the soldering process. I don't know how important this might be to you, but again, so it's just a case of getting the heat against the leg of the component and the pad, applying a little bit of solder and waiting for it to flow. As long as it's flowed, you can normally see when the solder starts to flow because it kind of smooths out, and you can see that it's covered the whole of the pad. So again, once the solder's flowed, you know that you've got a good joint. I'm doing these capacitors quite a few at a time now. There's no reason you can't put a load of them in the board and bend the legs over and then just solder them all in the same sitting. There's one more, there's two more that are here. So again, we just get the pad and the leg of the component fairly hot, let the heat move, apply the solder, and wait for it to flow. Looks good to me. So all 16 0.1 microfarad capacitors are in now, so that's stage 3.4 I think it was. Let me just check back here on the instructions. Yeah, 3.4. So they're all in the board now. Hopefully you can see that okay. I'm trying to get quite close so you can see the detail. So what I tend to do now is I've got a pair of these kind of snippy things, which are quite good at getting quite tight to the board. So where we've got excess legs on the board, we can just cut them off now. They tend to end up all over the shack, which isn't really a problem, as long as they don't land in things and short them out. We're okay, but you need a good sharp pair of these to do this properly. And there's one there that it looks like I've missed, so I'm going to just get the iron back in there. Some solder on that joint. Yep. Just reheat the other side as well. So that's fine now. Snip, snip. Snip, snip. So you know I'm cheating now and doing 2 legs at a time. Primarily because I'm lazy. You need to get a better job if you do them individually. This board's very densely populated, so we're going to end up with quite a lot of joints very close to each other when it's done. Again, that doesn't look very clever. It looks like I've missed one over there. It's very difficult to see you know, every one of these components, but that one clearly isn't in properly. And I'm also not convinced it's through the board properly. It felt like it moved a bit then. So I'm just going to go on the other side and just check the alignment of it. So I'm pushing it hard with this side of my finger, and I'm going to just heat the joint and make sure it snaps in tightly into place, which it has done now. So, last joint of these capacitors is there. The solder's all flowing nicely, so there's a warning in the manual about the sides that are connected to ground planes that they need a bit more heat. which is quite inevitable really, I suppose, but that's how the board looks so far. So we've got 2, 4, 5, 6 of the op amps in place. We've got IC3, I think that is, the socket for IC2, and we've got 16 0.1 microfarad capacitors in there, or 104, and that's the bottom of the board. Right, I'm going to do a bit more and catch up in a bit. So, all the ceramic capacitors are in the board now. There's a few things to note, and that it's upside down now, so I don't know what I'm talking about. The 2 capacitors between ICs 8 and 10, so it's these 2 here. This is C53 and 15. These 2 are actually in parallel, so it doesn't matter which one goes in the top and which one goes in the bottom. A number of the components are band specific, so some of the components up here, which are in the low pass filter, came out of my low pass filter bag. And the other thing to note is that these capacitors here are band specific, and in my particular case, which I'm building for 30 meters or 10 megahertz, there's no component fitted in here, so that's going to be empty. So as a consequence, I've actually got a few bits left, ceramic capacitors. I seem to have 4 ceramic capacitors left in my build, although this one, which is a 393, I think might be a duplicate, because there's one of those fitted to the board here. And I don't see any reference to it anywhere else, but I'm pretty confident that I've got all the components that I need on the board, and the underside of the board, the soldering is all quite good, neat and tidy, so hopefully you can have a look at this. So that's all the ceramic capacitors in. I've got 4 left, as I said, so I'll hang on to those in case I need them later, but so far so good. Moving on. So the majority of the board is complete now. I've been following the instructions step by step, taking my time and also checking my work as I go. A few things to note is that I had one 10k resistor more than I expected. I haven't found anywhere for that yet, but I'm sure that it's a surplus one. The input voltage protection diode, which is down here, I had 2 of those, and there's only 1 required in the kit. There's a warning about this capacitor in the instructions, saying it might be too tall, but it does also say that's only up to serial numbers 500 or something. But mine is the same height as all the other capacitors, so that's just gone in normally. And the other thing I noticed is there's 2 small inductors. There's one here and one here. These are listed in the components and in the instructions as being 100 microhenries. Mine are 47. You're very clear from the color coding. They're like short, stubby, fat resistors, about half the length of a resistor, and they look kind of chunky. Look like they've got a bit of an attitude, really. But mine have got a color code which clearly says 47. Now, they're on the power supply lines of the processor, so I don't think the inductance is going to be critical. So I've just put them in as is. The only other thing to note to watch out for is these pin headers here and here. No, not that one. There's a 3-way one there and a 4-way one there. I've used the headers from my low pass filter kit for here, so that I've got a long enough piece to put 2 7-pin headers in here. This was came from a 16-pin header. Now, there's also a requirement to put some test point pins in. There's 3 of them, I think, 1, 2, 3. I've decided to omit those for now, because if I'm going to stick anything in there, they're going to be scope probes or something, and the test pads on the board will be fine. But you might want to put single pins in there if you find you need to. But I thought I'd see what I wanted to do later. So the next thing in the instructions is to wind the toroids. Now, the first one I'm going to do is L4. This is an L37-2 toroid, which is a L37 is the size and the 2 is the material, and they're red. So I don't know whether you've got much experience at winding toroids, but there's a bunch of wire with the that came with the kit. I've pulled a bit off. I've pulled a length off, probably about a foot, and this requires 16 turns. Now, each time the wire goes through the center of the toroid, that's classed as a turn. So I've already got 1 because it's passed through once, and you have to try not to get any kinks or anything in the wire. So that'll be 2 through the center of the core 14 times. We should be roughly where we need to be. I'm going to spread the turns out a little bit so that they're fairly evenly spaced around the toroid. And then what I'm going to do, and the most critical thing I think that mistakes people make with these kind of things, is not getting the enamel off the wire. Sometimes you can get wire that's actually heat sensitive, so you can hit this with a soldering iron, quite a hot iron, and it'll actually melt the melt the enamel. I never trust that. The way I tend to do it, I just get a common or garden Stanley knife, put it on the bench, and I just scrape away at the wire so that we can see clearly that I've exposed the copper, and do that for all sides of the wire. So that should be about right now. Just do the top of that one, and then what I'll do is, now I'll get my soldering iron and get a bit of heat on there and try and tin those wires, which might be a mistake actually, because they may not go through the PCB as neatly. But what I want to do is make sure that the enamel is burnt off. You can see there's quite a bit of smoke coming, which tells me that it's still got some enamel on, but I can see that the solder is taking to the wire now. It smells good too. So hopefully you can see that the solder has actually taken to the ends of the wire. It's quite difficult to video this, I would imagine, but and then we're going to stick that in the board. This is L4, so L4 is down here. I'm going to stick that in the board. Make sure it sits fairly neatly. Pull the wires through from the other side. My tinned bits of solder have gone through neatly, so that's good. Turn it over. Let's apply some solder now. You may want to, I sometimes increase the temperature of my soldering iron, but I don't think it's going to be necessary here. In fact, I have a second iron which is always set to 450 degrees for this kind of thing, for hotter or bigger, you know, where I need a bit more heat, something that's a bit hefty, or where I really need to burn through something. But those have gone in nicely, so I'm going to trim the ends off that now, and let's have a look. So the inductor's in, the turns are quite nicely spaced, and I've definitely got a connection there. I can pull that quite tight. So that's the way I wind toroids, and that's the way I install them. So I've got the toroids for the low pass filter to do, which I'll do now, and then I'll come back with the video camera when we get to T1. So I've progressed now as far as getting T2 wound, and there's a diagram on a page in the the build instructions, by a guy WA4MZS Ed, and this diagram really is all I found I needed to wind the toroid. There's 4 windings, and for my build, which is 30 meters, there's 3 windings of 4 turns and 1 of 30 turns. So I've got my 30 turn winding around here, and there are 3 windings of 4. Now the way that I've done that is I've basically used one piece of wire, but I've copied the phasing that's on this diagram. So the way that it goes, if you go around in a kind of anti-clockwise or clockwise direction, you just need to alternate. So the start of this winding is on the bottom, so this winding finishes on the top, then the next winding starts on the bottom, finishes on the top, next one starts on the bottom, finishes on the top, starts on the bottom, finishes on the top. And the easiest way to do that is to not actually break it, so that where I've gone from the end of one winding to the start of the next winding, I didn't actually break this wire, I just created a loop, and then wound the 4 turns, created a loop, wound the 4 turns, created a loop, and only once I'd counted and got all the turns right did I then actually snap these loops and break off the the individual leads. I've then scraped all the enamel off this as best I can, and the next thing we need to do is try and fit this into the board. Now if I zoom out a little bit, hopefully you'll be able to see that each of these legs on this diagram has got a number associated with it. So it's 1, 2, 3, 4, 5, 6, 7 and 8, and then they've also labelled the holes in the PCB with the same number pattern. So if we actually look at the PCB now, try and zoom in again, it's really quite tricky, I'm sure you can appreciate that. So if we actually zoom in onto the board where this is going to be fitted, it's going to be fitted in here. So this is hole 1, 2, 3, 4, 5, 6, 7 and 8. So the bottom windings for the 3 4-turn phased inductors, the 3 4-turn windings, the bottom, the lower wire, goes into the 3 in the centre, and the upper wire goes on the outside, and then for the main winding the upper wire is in the bottom and the lower wire is in the top. So what I think I'm going to try and do is fit the big 30 turn winding plus the 3 bottom windings into here in one go. Try and get those 5 wires in one go, and then use a small pair of fine nose pliers to try and push these 3 off these 5 wires in afterwards, these 3 wires in afterwards, I'm sorry. So I'm going to fit the main 30 turn winding and the bottom legs of the 3 4 turn inductors, and then I'm going to try and use pliers to put the top wire in of the 3 4 turn inductors. So that's how it all works. This diagram looks excellent to me. The instructions confused me a little bit, I have to say, but that's probably because I'm so impatient and I couldn't be bothered to read them properly. But that's what I'm going to have a go at, so I'll pick that up in a minute. So I've done as I said I was going to do, and the 30 turn big winding, both ends of that are in the board, and then the lower winding of the lower leg, if you like, of the 3 4 turn windings, they've also gone into the board, into the center 3 holes. I've turned it over, I've given them a good yank, and then I've used a hot soldering iron to make sure that the enamel's burnt off properly. I actually did scrape the wires beforehand to make sure that they were down to the copper, but just in case there's any left, I made sure I applied a good bit of heat. So underneath you can see that we've got, hopefully you can see that we've got the legs sticking through, but they are now soldered onto the board. So what I'm going to do is I'm going to snip the extra lengths off these wires now. Blind, that's half my problem. So that looks okay to me now. So what I'm just going to do now then is with each of these remaining windings, I'm going to grab hold of the end with a pair of pliers, and I'm going to try and force that through the hole in the board. Once I've got it through, I'll turn the board over, find the wire on the other side and give it a yank. Now that looks alright to me. So that's the top one done. So while I've got it like that, I'll turn the board over, give it just one final tug to make sure it's fully through, and then again with a fairly hot soldering iron to make sure that the enamel is all burnt, apply a good bit of heat, make sure the joint is solid, and then trim off the excess. So just 2 more of those to do, a couple of sockets to fit, and then I think we'll be ready to test. So hopefully you can see the final inductor on the board now. Looks pretty neat and tidy to me. I've inspected the underside and the solder joints with a magnifying glass, and I can see that the solder has taken to the enameled wire, to the copper of the wire properly, and that the enamel has been scraped off correctly. So I'm pretty confident that that's going to be okay. So just a few more bits to stick on the board and we should be ready to test. So I've said my prayers to the QRP gods. I've plugged a power cable into here, and that's being fed from my bench power supply, which is at 13.8 volts. I've restricted it to 300 milliamps at the moment, just to try and make sure nothing actually caught fire, but I've turned it on and it seems to be doing exactly what it's supposed to do. So the instructions say that I may not see anything because of the contrast with the LCD, but in fact it does appear to be adjusted pretty accurately. I've been through the alignment process, but I'll demonstrate it very quickly. Long press of the left button takes us into the menu, over to menu 8, alignment, quick press of the left button. We need 8.7, which is the peak the bandpass filter. Press select, incredibly loud tone through the headphones, so I've put the audio gain down to minimum, and then while this is here you use a trim tool on this capacitor to peak for maximum reading here. Note that this number increments as this gets higher, so it's like a number of different scales almost as the signal gets lower. So get this as high as you can and then peak this appropriately. And then the IQ balance, you have to set that, but you have to set that with some gain, so you can't if you put the sort of audio control around midway and then you adjust one of the potentiometers here for minimum, and then here minimum again, and here minimum again. So I've been through that process, and I've set up the radio as I think is correct now, so I can go out to the alignment process, and the next thing we'll do is try and see if we can find any receive signals. This is actually RW9JZ. Quite a lot of QSB on the signal. I've just got a very low strung 30-meter dipole up in the garden. It's a long time of day really, I suppose, but it's clearly working, isn't it? I mean, and the CW decoder's working. It's not taken me a lot to build this, and it's clearly a really, really fantastic bit of kit. I'm going to have a lot of fun with this. So, all hail Hans Summers, that's all I can say. So I think we're pretty much done here for now. I've finished the receiver testing. I've also done some tests on the transmitter. And my output power is a little bit lower than I expected, so I might need to do a bit of debugging in the low pass filter. I've looked at the harmonic content though, and it's beautifully clean, the signal on the way out. You can probably see it on the oscilloscope in front of me. It's a beautiful sine wave, so there's very little harmonic content in there. And I've also had a quick look at it on the spectrum analyzer, and it's also nice and clean. So my conclusions on the kit are it's really very easy to build, although probably not an absolute novice project because of just the density of the components. The instructions are fantastic. The one issue that I mentioned earlier about the inductors being 47 rather than 100 microhenries, that's actually mentioned on the FAQ on the website, so that's perfectly okay. I also called L1, L2 a little bit earlier, or T1, T2, and just another piece of clarification, the L4 I think it is, let me just double check and confirm that, yes, L4 for my 30-meter build, there's 14 turns on there, I think I said 16 earlier. I hope you found this useful. I might do a review of the transceiver itself once I've got the hang of it, because there's quite a lot of excellent features in there, but I have to say I'm more than impressed. Well done, Hans and the gang.